Okay, I'll continue with present value annuity problems here. We're going to work a few problems here, so be different things we're going to try to solve for using this present value annuity formula. The first problem is pretty straightforward, except for one little trick you got to watch out for. Let's take a look at this problem. Suppose your parents give you $10,000 to put in a college trust fund. So I guess they really don't give it to you. They probably would put it in the trust fund. But so they put $10,000 in a trust fund, and it's going to be paid to you in equally quarterly installments over a 5-year period. Now, the money is deposited. It says you deposit the money, but again, they actually probably should deposit it because you'd probably spend it. So if they deposit the money into an account that pays 1.5% per quarter, okay, now I want you to pay attention close here. In the past, I always gave you the annual rate, and then when you divided by M in the formulas, it converted it to the quarterly rate. But here, I'm giving you the quarterly rate. So if you're given the quarterly rate, there's no reason to divide. So, in this example, 0.015 is the quarterly rate, not 0.015 over 4, because, again, like I said, I gave you the quarterly rate, not the annual rate this time. So anyway, back to the problem. How much are the quarterly payments? Now, we'll have to assume the account will have a zero balance at the end of the period. So, in other words, after the last payment is taken out, there's going to be a zero balance. Okay, so basically, we know that we're going to take payments out of this $10,000 trust fund, because it's really what that is. It's like a trust fund. So, we're going to take payments out each quarter of this. And the payments are going to reduce the balance of this $10,000. Doesn't that make sense? Every time we take a payment out, it's going to reduce the balance. So therefore, we're dealing with a present value annuity. Now, but we know the present value. In other words, we know the amount we could have if we just took the money and ran would be $10,000. But that $10,000 is going to be put in that trust fund. So the question is, how much payment could I take out each quarter so that when I take out the last payment, I have a zero balance? So you're going to use the payment formula of the present value annuity, which is actually the amortization formula, same formula you use when you calculate a car payment. But so the present value of this annuity is $10,000. Now again, we know I is 0.015, so we don't have to divide it by 4. So we'd have 0.015 here, and then divided by 1 minus 1 plus 0.015, and then raised to the negative 20, because quarterly payments over a 5-year period would be a total of 20 payments. So that would be 20. And then if you calculate this, you get 582.46. So if you take out 20 payments of 582.46, when you take out the last payment, your account should basically have a zero balance. All right, let's take a look at a time problem. Now on this time problem, I'm giving you one that's kind of a little strange, but I thought you might find this interesting. Suppose you purchase a washer and dryer from Sears for $1,000. And let's say Sears charges you a monthly rate, so again I'm giving you the monthly rate, not the annual rate, of 1.75% on the balance. If your minimum monthly payment were set at $5 per month, some companies love to do that, give you a very low monthly payment to entice you to buy something. So let's say they advertised your monthly payment would be $5 a month. How long would it take to pay off the balance? Okay, so let's use the formula. So I'm going to use the formula for present value. So let me just kind of go back up here and find it. So I'm going to use this formula for the present value of an ordinary annuity. And so what I know is, I know I can put $1,000 in for the present value. I can put $5 in for the payment. and I can put 0.0175 in here and here for I, and then I can solve for N, and that'll tell me how many periods it'll take me to pay off this debt. But here's what's interesting. So if I take that formula, put the 1,000 in there, the 5 in there, the 0.0175 in here and here. Now, first thing I'm going to do is divide both sides by 5. That'll get rid of this. So divide both sides by 5, and if you divide by 5 here, that'll cancel. If you divide by 5 there, you'll just get 200, right? Okay, so there I have it. I have 200 here, and now I need to get rid of this denominator. So if I multiply both sides by 0.0175, that'll cancel this, and then when I multiply 200 by 0.0175, that'll make this 3.5. So I get 3.5 equals just the numerator, 1 minus 1.0175 to the negative n. I went ahead and combined the 1 and the 0.0175. All right, now I want you to remember in algebra that when you had a minus term like this right here, minus this quantity, if I move it to the other side of the equal sign, then that minus actually changes to a plus. So that would give me a positive 1.0175, still to the negative n. And then if I were to take the 3.5 and move it to the other side, it would become a minus, so I'd have 1 minus 3.5, and so that's how I got negative 2.5. Now, what we normally do when we want to solve these is we take the natural log of both sides. So let's say I take the natural log of this side and I take the natural log of this side. Well, grab your calculator and plug in the natural log of negative 2.5 and see what happens. Your calculator is either going to tell you that that number does not exist, or if it does give you a value, it's going to give you an imaginary number. So the natural log of negative 2.5 is actually not a real number. It's an imaginary number. So therefore, the only way that you could ever pay this debt off by paying $5 a month is in your dreams. Okay? So because, and I'll let you do this, if you calculate the interest charge for the first period, remember you would just take the $1,000. So you would take the $1,000 here and you would multiply it by the periodic rate, 0.0175. And so if you take the 1,000 times the 0.0175, you would get $1,750. So what would happen is at the end of your first month, you'd get a bill for $1,750, but you're only going to make a $5 payment. So now you owe $1,012.50 for the next period. And so then for the next period, the interest would go up again, and your $5 payment wouldn't cover the interest. So your payment, in other words, your balance would just keep increasing. So that's what happens if you don't pay at least the amount of the interest on a loan like this, then you'll never pay it off. So you have to pay more than the interest charge each month. Otherwise, you'll never pay it off. So anyway, I don't know that that's legal to charge you less than the interest charge, but you can certainly see that it should be illegal. All right, let's take a look at another example here. Let's say you found your dream home and it sells for $120,000, and you can pay 10% down and finance the balance at an annual rate of 9.6% compounded monthly. Question number 1, how much are your payments if you pay monthly for 30 years? Well, first of all, remember you're going to pay 10% down. So calculate 10% of $120,000. So that would be $12,000. And then subtract $12,000 from $120,000. And that means you're going to finance $108,000. Because you paid $12,000 down, so you're only going to finance $108,000. So that would be your present value. Now we want to calculate the payment, so I'm using the payment formula of the present value annuity formula. So now the payment would be 108,000 times I, which would be 0.096 over 12, divided by 1 minus 1 plus I, 1096 over 12, raised to the negative 360. Now that turns out to be 916.01. Now, so that means your payment to cover your principal and interest each period would be $916.01. Now, what's interesting is if you calculate the interest, that means you're going to pay 360 payments of $916.01. But on the other hand, if you had $108,000 cash, you could have just paid the present value of $108,000. Well, that means that instead of paying $108,000, you're going to actually pay over $300,000 over those 30 years. And so if you take the difference of what you're going to pay over those 30 years minus the present value of the home, that tells you you're going to pay a total interest of $221,763.60. So that is a lot of interest charge there to pay on that home. I will tell you this, this rate's kind of outdated. The rates are probably more like 4.5 to 5% right now. Of course, they could go up by the time you view this. All right, now let's go ahead and determine the payoff after 100 payments have been made. So let's say you make 100 payments and you want to know what the payoff is after you make 100 payments. Okay, well here's the trick. In order to find the payoff, what you want to do is you want to calculate a new present value. So what you want to do is calculate a new present value, but you want to calculate it on the number of remaining payments. So if I've made 100 payments, then that means out of these 360 payments, if I've made 100 of those, that means I still have 260 payments left. So basically what I want to figure out is what is the present value of my 260 remaining payments. So I just use the present value formula with my payment of $916.01, and I want to find the present value of making this payment over the next 260 periods. And when you calculate that present value, you'd have $916.01 times 1 minus 1 plus I to the negative 260 over I, and that will give you the new present value. So that means you could actually pay the house off after those 100 payments with $100,000, a little over $100,000. You could pay the house off. All right, now that's not that really, so you really haven't reduced the balance much, have you, over those 100 payments? Well, that's because you got a high interest rate and you're still early in the loan. So, you know, you really don't start really working the balance down till you get halfway through the note. Okay, now D part says change the rate to 8.4% at the time to 15 years. So I'll let you do that. I just changed the rate to 8.4 and I changed the time to 15 years. And so that gave me 180 periods instead of 360. And notice the payment is $1,057.20. And then E says compare the interest rates. Well, if you make 180 payments of $1,057.20 and subtract off the 108,000, then that means you would only pay an interest charge, a total interest charges of $82,296. So look at how much you would save in interest if you chose to finance it over 15 years at 8.4% rather than 30 years at 9.6%. See, this is the interest you would be paying over 30 years. This is the interest you'd pay over the 15-year note. So you'd save over $139,000 in interest. And so that's all I have on this video. I'll let you look at number 7. And on that one, you can just freeze the video and read through number 7. I'm not going to go over that one because I've already worked problems like both of those. And then I'll finish up this when I get to home equity on the next video.